Hey everybody, let's talk about centripetal force. So in this application, centripetal is an adjective, right? Like you can have forces like gravity, tension. Centripetal just indicates the direction of the force, which is toward the center, right? Center seeking is what centripetal means. So let's say you're designing a wind turbine prototype. Again, like this thing is just cranking, right? Just rotating. So it'd be really bad if like this thing failed right here. Like if it broke, this turbine blade would go flying, which would then make this entire thing unbalanced, right? So then it'll start vibrating. It'll just be a catastrophic failure. So something like this would be important work. So just to simplify the model for now, for analysis, let's just break it down to more like there's a post with a rope and then you put a test mass right here. So it's like a tether ball going around in a circle. So this is a horizontal circle. And for simplification, let's say that tether ball is going at a constant speed. So constant speed. The direction keeps changing, but the speed remains the same, the magnitude of the velocity. So let's say we measure this angle, we know the length of this string, we know the mass of this ball, let's say. Okay, so can you tell me what's the tension in the rope? Okay, so let's draw the free body diagram. There's that ball. There's the string, right, that rope. So there's tension. And then it has weight. And that's it, right? That's it. There's tension, there's weight. That's the free body diagram. Okay, so here's the question. This is going in a horizontal circle. So let's say this is the front view, right? This is the front view. And then the circle is kind of like this, right? And top view is more like, right, it's over here, the ball going this way. So which way is centripetal? Which way is toward the center of the circle? Right, the center of the circle is here. So centripetal is this way, right? From the top view. From the front view, which way is the center of the circle? Here, 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 right? So it's this way. So that means this way is centripetal, this way. So I'm just going to draw my coordinate axis in that direction. And then I'll pick another axis. I'll just call this one x. So I drew my x-axis in the centripetal direction. Okay, and then if I just look at this geometry, so that's got to be here. So now let's write Newton's second law, decomposed. So in the x direction, I got t sine, and that's it. In the y direction, cosine. Okay, and since I know that it's going in a horizontal circle in the x direction and in the z direction, it's certainly not moving in the y direction. So I'm going to cross this out. Furthermore, this acceleration is centripetal. And then do you remember centripetal acceleration is the one that looks like this? Okay. So I'm just going to substitute that in here. I'll just rewrite this. V squared over R. In this example, what is R? Right here. Here to here, which is L sine theta. Okay, and then that other equation. Okay, so if we're given, right from the picture, like if we know the angle, the mass, and the length, mass, angle, length, what do we know and what do we not know? So we don't know this, we don't know the speed, we don't know this, and there you go, right? So 2 equations, 2 unknowns. So we would be able to solve for the tension in the cable, and we could substitute it there, and actually we would be able to solve for the speed of the ball. Okay, so let me know if you have questions about this one. I'll see you on the next video.